All right, good morning. Welcome to the Yongsan Baptist Church English Sunday School class on October 31st, 2021, Reformation Day. Okay, continuing in our series on biblical creationism, we are now on the 7th week of section 4, looking down at evidence from geology. Last week we looked at evidence number 4 in this special segment from Answers in Genesis on 6 specific evidences from geology for a worldwide cataclysmic flood. That lesson was sand transported cross country or across the continents. And today we'll look at evidence number 5, no, slow, and gradual erosion. I thought I clicked you. No, slow, and gradual erosion. I'd like to first consider a feature that is often overlooked: the boundaries between rock layers. What should they look like? Good morning, sister. Please join us. If laid down during a single global flood. The dominant view today is that slow and gradual processes, or uniformitarian processes, similar to the processes we observe in the present, can explain the thick, fossil-bearing, sedimentary rock layers that we see all over the earth. These slow geologic processes would require hundreds of millions of years to deposit sediment in a particular area. Furthermore, this popular view holds that slow weathering and erosion would take place gradually to wear away the Earth's surface to produce the relief features that we see, such as hills and valleys. So they claim, on the one hand, slow deposition over millions of years of each of these layers of sediment, and on the other hand, that erosion and weathering would carve out hills and valleys and mountain ranges and things like that. But this view has a problem. If the fossil-bearing layers, the sedimentary layers, took hundreds of millions of years to accumulate, we would expect to find massive examples of extreme weathering and erosion between these layers. But we don't see that virtually anywhere. We see a lot of these very straight, very delineated sedimentary layers that look like they've been deposited without any possibility of erosion or weathering in between them. So the boundaries between many of these strata should be broken and topographic, but they're not. The cataclysmic global flood described in Genesis 7 and 8 would lead us to expect something like this. Most of the fossil-bearing layers would have accumulated in just over 1 year. Under such catastrophic conditions as the flood would produce, even if land surfaces were briefly exposed to erosion, such erosion, called sheet erosion from massive floodwaters, would leave the ground smooth and flat and not topographical. It would be rapid and widespread across large areas. And these smooth surfaces would not create localized, so that the erosion would not create localized topographic relief like hills and valleys. That doesn't happen with sheet erosion, with massive moving of water. But that's what we see forming today at a snail's pace. When we look around today, we see it rained a little bit, there's a little bit of erosion, or we see the waves on a seashore kind of eroding the rocks a little bit every year. That slow, gradual erosion that carves out depressions and makes hills and valleys. That's not what we would see from the runoff of a massive flood. So if the Genesis flood caused the fossil-bearing geologic record, we would only expect to see evidence of rapid erosion or no erosion between the sedimentary layers. Which evidence do you think we find? The evidence of a flood, that's right. At the boundaries between some sedimentary layers, we find evidence of rapid erosion. And in most cases, though, the boundaries are flat. They're featureless. They're knife-edged, allowing for no erosion whatsoever within that period of time of deposition. So there's no evidence of erosion in most of these, in between most of these layers. And that is consistent with the Genesis account of a global cataclysmic flood, and it's inconsistent with the common model of long periods of elapsed time. The Grand Canyon, as we've spoken about many, many times, and will continue to, is a marvelous example in the southwestern United States, over here, in the southwestern United States, of numerous strata that we can see all of these that are labeled here, all these different kinds of rock, one after the other. So these are strata of sedimentation. And even with all of these examples, today I'm only going to focus on 4. So we'll pick out 4 of these that are typical of the other ones. These boundaries appear at the bases of, if you look at figure 1 in your notes sheet there, that's on the first page, they appear at the base of the Tapeats sandstone, the base of the Red Wall limestone. So the Tapeats is down here, in between it and what's called the Great Unconformity. Then at the base of the Red Wall limestone, where it blends with the Muav limestone. Then at the base of the Hermit Shale, and the base of the Coconino sandstone that's just above the Hermit Shale. Those are the 4 boundaries we will look at today. Below the Tapeats sandstone, that's the lowest one that you see on the figure in your notes. The strata below this, okay, go ahead, 2 clicks. Just for the sake of seeing it a little more clearly and less rocky, this is the Tapeats sandstone layer here at the bottom. So right there is the boundary at the base. And as I said, the Great Unconformity, it's not a straight line. And it goes up and down because all of this here at the bottom of what you can see in the camera is metamorphic rock. So it's base stone, really hard rock. But then over here are tilted sediment layers, right? And we talked about that before, about tilted sediment layers across beds and how water flows in one direction for a while and then can flow in another direction. And so all of these generally straight above the level you can see in the Grand Canyon, above the ground, right? All of these generally straight layers laid down after something pushed these layers into a tilt. But that Great Unconformity is a visible boundary at the bottom of the Tapeats sandstone layer, and it shows that it's been rapidly eroded and extensively scraped flat, or planed off is the term. We know that this erosion occurred on a large scale because we see its effects throughout the entire Grand Canyon. Everywhere there's Tapeats sandstone, that layer between this lowest sandstone level and all of these tilted, what's called the supergroup of sediments, and the basement rocks of the metamorphic layer. That layer of the Great Unconformity is seen everywhere across the Grand Canyon. It's a massive erosion that affected many different underlying rock layers, as we've discussed. There's granite, metamorphic rock, and sedimentary rock underneath it. There are 2 evidences that this large-scale erosion was rapid. First, we don't see any evidence of weathering below that boundary. That's figure 2 in your notes on the second page, or the back page of your copy. It's at the top there. We don't see any evidence between the layers. I know it's kind of small and maybe not easy to look at, but between what the Tapeats and then the Hakatar is there in that photo, there's no evidence of any kind of weathering, of any levels changing, of any soil between it where it would be blown in from somewhere else. And if there were weathering, we would see soils and other signs of that weathering and erosion, but we don't see it at all. And second, we find boulders and features known as storm beds in the Tapeats sandstone above this boundary. The only way for the boulders and storm beds to be in the Tapeats sandstone above the unconformity, that's in the second photo there in your figure 3, the second photo on that second page there. There are boulders above the boundary. So for boulders to be moved above the boundary between sandstone and sandstone, it had to have been massive amounts of flooding for rapid erosion. Because I don't know if storm beds are a term that they use in geology for where they find evidence in rock layers from a hurricane or a typhoon. It has to be massive amounts of weather at high speeds for a long period of time. It can't just be runoff from a seasonal storm. It has to be a hurricane or a typhoon to produce what they call a storm bed. So the storm beds and the boulders are both evidence of massive rapid erosion because neither boulders nor storm beds can deposit slowly. You can't have trickle water that moves a boulder across a surface. It has to be a flood to move rocks that are bigger than us, right? Okay, so that's the Tapete sandstone layer. Then we have the layer at the bottom of the red wall limestone here, between it and the Muav limestone. Below the base, the underlying Muav limestone has rapidly eroded in a few localized places like this to form a channel. So it was rapid erosion in a few places, not along the entire surface. And in those places, other limestone and sand filled in the channel. And in this case, it's this one we refer to as the Temple Butt Formation. But that is a different concentration of sand and lime that shows up as a different sort of layer within the layer. But it's from a channel from, rapid erosion, not a slow trickle over time, because we would then see evidence of that erosion all across the level, all across the layer. But most of that transition from the Muav to the red wall limestone is flat and featureless, which again are hallmarks of continuous deposition of sediment, not slow and gradual every so often over hundreds of millions of years deposition. In some locations, the boundary between the Muav limestone and the red wall limestone is indistinguishable. It's impossible to find the line, and that is evidence that there was deposition of both types of minerals at the same time. So they intermingled. But it's a perfect layer. But the conventional belief, or what they teach, and actually I cut it off of the side of the photo here, but this is from an evolutionary science textbook, and it has the hundreds of millions of years along the side of this chart. And right here at this level between the Muav, the Temple Butt Formation, and the red wall limestone, they purport that the Muav limestone was laid down 500 to 520 million years ago, and that this particular channel that was filled with a different limestone was supposedly deposited 100 million years later. And the red wall limestone that covers all of it, some places completely smooth, some places over the top of the fill channel, was another several million years later. But based on the evidence, it's much more logical to believe that all of these layers of limestone were deposited continually without any intervening millions of years. You can't account for those millions of years without a lot of faith. The next layer we'll look at is below the Hermit Formation, toward the top. So the base of the Hermit Formation as it connects to the Esplanade sandstone beneath it. This is often cited by geologists, secular geologists, as an evidence of erosion that occurred over millions of years and after sediments stopped building up entirely. There's a problem, however, because the evidence between these two layers indicates that water was still depositing material even as erosion was occurring. So we had deposition and erosion at the same time between those two layers. In places, the shale of the Hermit Formation, because that's a different kind of rock, is intermingled with the Esplanade sandstone beneath it. It's a process called intertonguing. So as the rock is forming, it's interwoven, right, or intermingled with the other layers. So sandstone is quartz sand, and the shale is a different kind of mineral that forms sort of silty rock. But those two are obviously distinguishable to the naked eye as well as to microscopes. But as they were forming into rock, meaning as they're drying and hardening under pressure, they intertongued with each other, as much as these boards in the floor are intertongued together to hold each other. So that intertonguing process, you can see in figure 5 of your notes. It's not a great photo. Again, I had to blow this up a little bit to be able for you to read it. But there all along this layer, there is evidence of this intertonguing. It indicates a continuous flow of water with both the silty mud and the quartz sand into the same place. And so there couldn't have been millions of years between these sediment layers because they would have been completely separate. They could not have intertongued over millions of years. All right, so that's another one. Just above the Hermit Formation now at the base of the Coconino sandstone. So below the Coconino, I always want to give it a S sound instead of a hard C. The Coconino sandstone and the Hermit Formation is a flat, featureless, knife-edged boundary from one end of the Grand Canyon to the other end. There's no breaks, no channels, nothing between the two, completely flat the entire way. But there's no evidence of any erosion happening between this shale and the sandstone above it being laid down. That alone, with no evidence of erosion at all, is amazing. Yet somehow, outside of the Grand Canyon, elsewhere in Arizona, there is a place where there's over 600 meters of sandstone, shale, and limestone called the Schnebly Hill Formation that sits on top of the Hermit Formation below the Coconino Sandstone Formation. So just like this, right? This is called the Surprise Canyon Formation, right? This big space of rock that is in between the red wall and the formation above it. So if this was the only one, it would be weird, right? And so in this case, the entire Grand Canyon, that level, those two layers, are completely flat and featureless. No erosion, no time should have taken place between those deposits. But those same two deposits, as they run across Arizona, there's another spot where they do open up and there is a formation there. So because that deposition is there, the evidence of the supposed millions of years of erosion at this boundary in the Grand Canyon, while the deposition was occurring elsewhere, there's no evidence that those two things could happen at the same time. If there's this enormous thickness of sediment deposited over, I think they say 500 million years, as conventionally believed, then some boundaries between layers should show evidence of millions of years of slow erosion. Even the erosion we see now, if we go 1,000 years, things can disappear. I don't know if anyone saw the article outside of Ecuador. They had a natural arch out in the water that they called Darwin's Arch, right? Because it was supposed to be a pillar to him coming to, they named it after him because he came to the Galapagos and then wrote his book about evolution, and everybody praised Darwin for his theories, so they named this natural arch that was out in the water after him, and a lot of divers would go dive it to see it, and there was a dive group that was on a boat going to see Darwin's Arch, and it collapsed. The top of it had eroded enough that the arch part in the middle completely collapsed down into the water while they were there. They caught it on video. And the funny thing about this was that shows erosion and decay, and that long gradual processes over time don't make anything better or smarter or faster or more adaptable. They make things worse. Because over time, we decay, we fall apart, we die. There's no proof in nature that over time we get better, that we add information, or that we evolve into something greater than we were. We adapt, but all of that mutation, all of that change, usually comes at the expense of something else. We lose, we don't gain over time. But they still, once it collapsed, it fell apart, right? Just as if you really give it honest study, the theory of evolution that Darwin started falls apart under pressure and time. But they took those two side parts of that natural rock structure and then renamed it the Pillars of Evolution, because they can't let go.
But they're not holding up nothing.
They're not holding up anything, that's right. They're holding up air, which is still fitting and makes me laugh. Okay, so just like that, right, we see that if there are just hundreds of years, things will decay, they will fall apart. Erosion can tear up and tear down and move away. So if that's the case in hundreds of years, how would we ever guess that in hundreds of millions of years there wouldn't be enough erosion to just get rid of this entire formation of rock? The entire layer should be gone. It should have been washed away somewhere else. But if it's still here and still here, yet somewhere else there's 600 meters of rock in between those two layers, that had to have all happened at the same time. That's the only logical answer, is that it happened at the same time in a worldwide Genesis flood. So the fossil-bearing portion of the geologic record, that's the sedimentary rock, consists of tens of thousands of feet of sedimentary layers. 4,500 feet of that is represented in the Grand Canyon. These boundaries between layers should show all kinds of evidence of erosion over these hundreds of millions of years, and we don't see that. But if the Genesis flood was true, and all of this happened in just over a year, then we would see boundaries between layers that should show evidence of continuous, rapid deposition, which would only occasionally show rapid erosion or no erosion at all. And that's exactly what we find in the geologic record, not just in Grand Canyon, but all over the world, as illustrated by these strata boundaries that are obvious in those photos, just like that one. You don't have to have me write Coconino sandstone and Kaibab limestone and Toroweed formation to notice that those are three distinct sedimentary layers. Those layers are obvious. If you go to the Grand Canyon, there's nobody that can tell you that those are not layers of sediment. Okay, completely obvious. But there is one more that I want to get to really quickly. One more great dramatic example of erosion and how it doesn't take millions of years. Last week, I left you with this photo at the end of the lesson and asked one question. I hope you thought about it. The question was, is this a drying riverbed that slowly, over a long period of time, with a little bit of water, carved out this canyon? Or is this a drying riverbed that's the evidence of a massive stream of water that carved out this canyon in a little bit of time? I'll answer the question for you. This is an image at the base of Mount St. Helens in Washington State in the United States, the northwesternmost state of the contiguous United States. At Mount St. Helens in May of 1980, there was a volcanic eruption that completely changed the face of that area of Washington, about 90 miles south of Seattle. So that we can quickly get through it, I have a video that is it's about 3 minutes long, and it's the most concise breakdown of what happened at Mount St. Helens I've seen, and then we'll talk about it for a minute, and then we'll be done.
On May 18, 1980, Mount St. Helens, located 95 miles south of Seattle, Washington, erupted. The eruption was triggered by an earthquake centered beneath the mountain that measured 5.1 on the Richter scale. The lateral blast swept out the north side of Mount St. Helens at 300 miles per hour. With temperatures as high as 660 degrees Fahrenheit and the power of 24 megatons of thermal energy, it snapped 100-year-old trees like toothpicks and stripped them of their bark. Before the famous eruption at Mount St. Helens, scientists were mostly familiar with slow-acting examples of geologic change. But at Mount St. Helens, geologists watched the Earth's surface change quite rapidly. Icebergs were buried in hot avalanche material. They melted and formed badlands in days. Eruptions on May 18 and June 10 produced fine layers in hours. On June 10, mud flows cut zigzag canyons 100 feet deep in soft sand and mud, complete with perpendicular side canyons. Canyons that are reminiscent of the geography of Grand Canyon, only 40 times smaller and clearly produced within hours. Mud flows over the following decade cut hundreds of feet into solid rock in just days of cutting time. Fallen trees formed a log mat on the surface of Spirit Lake and dropped bark to the bottom of the lake, accumulating up to 3 feet of bark peat in just a couple years. And vertically floating logs sinking to the bottom of the lake resulted in buried trees in only a decade, similar to the trees of Yellowstone's fossil forest, which are also buried in volcanic layers. Even though Mount St. Helens is a very small catastrophe compared to the flood or the major catastrophes immediately following the flood, it provides a better clue to what happened in those times than the slow geologic processes which are most commonly seen in the present.
All right. So, the explosion of Mount St. Helens. I hope you could hear that on the video. I know we definitely heard it in here. The explosion of Mount St. Helens not only drastically changed the landscape of that area south of Seattle in just a matter of months, but it also dug deep holes in the idea that millions of years are necessary for the formation of rock layers, canyons, and fossils. Mount St. Helens clearly testified that these things do not require long ages to form. So the biblical account of the flood describes the water sweeping over the continents to cover the whole earth. The waters flowing around the earth would have catastrophically eroded sediments from some locations, transported them long distances, and rapidly deposited them. Because the waters flowed continually, that's the word used in Genesis 8, verses 3 and 5. The waters flowed continually from off the earth after the flood stopped. Then erosion, transport, and deposition of sediment would have been continually rapid. So billions of dead plants and animals were rapidly buried and fossilized in sediment layers that rapidly accumulated with only rapid or no erosion at their boundaries, because they were deposited just hours, days, or weeks apart, not hundreds of millions of years. The evidence declares that the Genesis flood really happened just as God said it did in His Word, as a major event in Earth's history. And now, I'm going to say one more thing before we go. This is just my theory. This is no one's official position as far as I know. It is not doctrinal as far as I know. However, I'm convinced that God sends disasters like Mount St. Helens every few generations for 3 reasons. I'm convinced that He does that. He allows that, or He does that, either way, to demonstrate His sheer power and control over creation. We are not God. He is. We can't control the weather and all things that are around us, but He can. Second, as a reminder of the fallen nature of our world because of judgment on man's sin. If the world was perfect, we wouldn't have volcanoes and hurricanes and tsunamis and earthquakes. We wouldn't have floods. We wouldn't have mudslides. Those things are evidence of the judgment on the world in the flood because of the vast, rampant sin of man. And 3, and this is the controversial part, I think that these disasters, like Mount St. Helens, are a gift from God. They're a gift of contemporary evidence, of modern day evidence, of just what is possible. Because just like that verse that popped up at the end from 1 Peter, that scoffers are willingly ignorant of what happened in the flood. When they didn't see it, and you can't convince them of it, God's like, okay, here's some modern evidence to prove to you that what I said happened. can happen and did happen. So in his grace, God gives us a curiosity to wonder about these things we see. He gives us a capability to learn and to study his word and the world around us, and to make sure that we see how those two things agree, not how they are in conflict. But then he gives us the capacity to understand it, and that is huge, that he wants us to know him. He's given us the curiosity to seek him, the capability to learn and to study, and the capacity to understand it, even if only in part for now. But even if only in part we can understand, shouldn't we? Shouldn't we believe that what God said happened, did happen, because of what he's given us? So that gift, just as Jesus told Thomas, blessed are those that believe without seeing, when you believe because you've seen. But at the same moment, Jesus said, it's better to believe without seeing. But he still made the effort to let Thomas see. And God is doing the same thing for us. He wants us to believe without seeing. But he gives us those great cataclysms like Pompeii and Mount St Helens to see, so that we can know and believe. And it's a great lesson to take away from geology, something as unknown to most of us as studying rock layers, that you can take God at his word. Amen. Next week, that's what this photo is for. We're going to look at the sixth evidence in this mini-series about geology as evidence for the flood. And it's one of my favorites. It's folded rock layers. It's a lot of fun. So, don't miss that next week. Let's pray.